Okay, these are the practice problems for section 4.3. Well, that wasn't so neat. Maybe I should just underline 4.3. Okay, I want to make sure it's focused. There we go, camera. Okay, it says a mixture of carbon monoxide and oxygen are placed in a container as shown opposite. A reaction occurs forming carbon dioxide. Which of the following best represents the contents of the box after the reaction has proceeded as completely as possible? So I'm assuming this is where, excuse me, this is already going to start off. So off the bat, we have 1, 2, 3, and 4 carbons. So, and we're forming CO2. So it couldn't be this one because there's more than 4 carbons here. And then here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 oxygens. So carbon. So there's 4 carbons. So there would be 4 CO2s. So there would be 8 oxygen, and then there would be 2 oxygens kind of left over. So I can't think this is the one that we see. That makes sense. Okay, let's look at the next problem. And problem number 2, which of the following particles best represents the products when 4 molecules of H2O decompose into water and oxygen gas at room temperature? Decompose into water and oxygen gas. So H2O2. So what's happening is it's going from H2O2 and it's turning into H2O, or maybe let's say two of these turn into H2O, and the extra oxygen would turn into O2, and that's why I drew I wrote the second H2O2 because you want there to be O2. It's a diatomic atom or molecule, and so when we look around here, we have H2O, right, and oxygen. So this one it can't be because it's H2O and H2, so there couldn't be this one because these are the hydrogen ones, right? And so the only answer that it could be is this one. This is the only one where we see water, right? H2O, and we see O2. Like I said, right here. Right, next problem. This diagram shows H2 and N2 in a closed container. Which of the following diagrams would represent the results if the reaction were to be happening? Represent the results. So after, so we would want to see 2NH3, right? And it's starting out with 1, 2, 3, 4, 5, 6 N's, and then 1, 2, 3, 4, 5, 6, 6 H's, right? And then we end up getting this product, right? 2NH3. So we're only using 2 of the right nitrogen, so we get 2N, right? So and then H3. So now, well, the H's I think we'll use all of them because 3 times 2 is 6. So 6 H. Right. So this is what our end result is. This is what we're seeing here, right? And then, so 2n and 6h. So what's going to be left over is going to probably be 2 n2s. So I think that is what will give it away. So we could look for 2NH3, and I believe here we see 2NH3s, right? And then we're going to have 2 N2s left, and right here, this is what N2 looks like. So this is the only answer it could be, and that's E. None of the other answer choices have what the end result is. Oh, this could have been a trick answer. This is everything reversed as this one. But you just have to look here at this legend, and you'll see that it's 2 N2s that are left over, not 2 H2s. Okay, moving on. Which of the following particulate diagrams shows the formation of water vapor from hydrogen gas and oxygen in a rigid container at 125 degrees Celsius? So I'm going to assume the oxygen would be larger circles represented, and then the hydrogen, since hydrogens are smaller circles represent. Off the bat, I know the diatomic molecules, remember, and never have a fear of ice cold beer, right? And so these things exist in pairs, right? So it couldn't be this because nothing here is a pair. It couldn't be this, nothing here is a pair, right? And so it could be either of these. And then, so what are the difference between these two? I guess the proportions are something we would have to look at. So let's see. We would need 2 times as many hydrogens. So we need 2 times as many hydrogens as we have oxygens. So if we look here, we have 1, 2, 3 oxygens, right? And then we have 1, 2, 3, 4, 5, 6. Oh, it's definitely C. And then here we can just, for kicks, we can see we have 1, 2, 3, 4, 5, 6 oxygens. But we have 1, 2, 3, 4, 5, 6. And that's, if this were to be the case, we would have, half of these we wouldn't use. So 3 of these would need to end up here as diatomic. So it could only be C. C is the only one in the right proportion. Okay. These are actually quite easy. Okay. A mixture of H2 and O2 is placed in a container as represented opposite. The H2 and O2 react to form H2O. So here it's a very similar as we've done before. We have 1, 2, 3, 4 O2s. right? And then we have 4 hydrogens as well. Okay, so 4 H2s. 4 of these as well, and it's forming H2O. So we're probably going to use up all of these, right? But these we're probably not going to be able to use up all of them because H2O has a 2-to-1 ratio, right? It's really important to think about the ratio here. It's a 2-to-1 ratio, and so H2O. So how many H2Os would we create? We would create 4 H2Os, right? And then that would take 8 hydrogen, and that's all of that would be done. And then it would create 8 oxygen, but we don't need all 8 oxygen. We only need 4. So the other 2 would create 2 O2s. So I think the right answer will have 4 H2Os, and this kind of looks like it has the 4 H2Os. And we got to double check here. Oxygen is the white circle here, and would have 2 O2, so B is the answer. All right, that was a short video.